In this question, we're asked to determine whether an ionic compound will form, and then if it will, the empirical formula of that compound. So here we have sulfur and we have strontium. So in order for an ionic compound to form, we need a metal and a nonmetal. So what you want to do is use your periodic table to find sulfur and strontium. In this case, strontium is a metal, and sulfur is a nonmetal. So yes, an ionic compound will form. In order to determine the empirical formula of the compound, we need to know the charges. So strontium's in 2A, so it wants to lose 2 electrons to be like a noble gas, so it'll be plus 2 or 2 plus. Sulfur is in 6A, so it wants to gain 2 electrons to be like a noble gas, so it will be minus 2 or 2 minus. So, first, yes, an ionic compound will form. In order to find the formula of the compound, we put Sr 2 plus, S 2 minus. Now we cross the charges. We get Sr2, S2, but because there's a common denominator, they're the same number, so the common denominator is 2. We do cancel them out. So in the simplest possible form, the empirical formula here is SRS. Next, we have cesium and sulfur. Cesium is a 1A metal, so its charge in ionic compounds will be plus 1, or just plus. So, sulfur we already know, so we have a metal and a nonmetal. So we have cesium plus S2 minus. Bring the number down, not the charge. In the case of the 1, you don't write it on the top or the bottom. And what you get is CS2S, which does not have a lowest common denominator. So yes, you can form an ionic compound, and its formula is CS2S. Next one, we have cesium and calcium. Cesium is a metal, and calcium is a metal. Metals and metals will not form ionic compounds because there's nowhere for the electrons to come from. Metals like to, for the electrons to go, I should say. Metals like to lose electrons. They like to lose those electrons to the nonmetals. They will not lose them to each other most of the time. So here, the answer here is no. They will never form an empirical a compound, an ionic compound between two metals. Last one, strontium and fluorine. So strontium, we've already had. It's Sr2 plus. We used it in the first example. It's right there. Fluorine is a 7A, so it likes to gain 1 electron. So you end up with F minus. Cross them. Just bring the numbers down, not the charges. Again, if they're a 1, you don't put minus 1 here, and you don't put a 1 down here. So it's Sr, no 1. F2, there's no common denominator. So yes, they can form a compound, and the empirical formula is SrF2.